Okay, ladies and gentlemen, today I gave you a quick intro to solving right triangles using Sohcahtoa and Pythagorean theorem. So here we go. This is one of the last two problems, so I figure I would do the last two problems on today's little worksheet. Okay? And hopefully this is a video that you will watch over again numerous times. Same old story. So here we go. So first of all, notice that I have a right triangle right here. And first thing we always do, guys, is we find the angle we're going to reference. Everyone agree 69 degrees is the angle that's given to us besides a 90. We never use a 90, by the way. We always use one of the acute angles. So with respect to 69, does everyone notice how the 15.3 is on the opposite side? I'm going to call it O for opposite. It's on the opposite side. And we also have this missing side in green over here, which I'm going to call the adjacent side. A for adjacent because it's right next to. And of course, everyone hopefully knows the purple side right here is the longest side. It's called the hypotenuse. So H for hypotenuse. Okay, so if we at least agree we're familiar with Sohcahtoa, some old hippie caught another hippie tripping over apples. Okay, well notice, let's go ahead and find the we have the opposite. Let's find the adjacent side. So what uses O with A? Well, if you look at Sohcahtoa, that's tangent, right? So therefore, I know that the tangent of 69 degrees must somehow equal 15.3 divided by the missing side A, the adjacent side. Notice how this ratio is backwards over here, guys. So one nice little neat trick you may appreciate is let's put this over 1, and can't we cross multiply? Let's go ahead and do that. So we have A times the tangent of 69 degrees, and that equals 1 times 15.3, which of course is 15.3. And now, all I need to do is divide by tangent 69 degrees, both sides, right? Solving like any other equation. And now the tangent of 69, of course, is gone, and I have A equal to whatever that number is. And I just so happen, if you look at the computer screen right here, notice how I took 15.3 divided by the tangent of 69, and I got 5.87. Now let's just round off to the nearest tenth, so that's 5.9. Everybody agree that that number right there, rounded off to the nearest tenth, is 5.9. So now what? Well, notice, guys, let me clean up my picture here. What we have now, you see, is we know 15.3. We also know the shortest side is 5.9. Well, let's use Pythagorean theorem, right? Let's take A squared plus B squared. And I know that equals C squared. C being that missing hypotenuse, which I just marked in green, right? And I just so happen to have done the math already. If you look at my computer screen right here, or calculator screen, you will see 5.9 squared plus 15.3 squared is 268.9. If I take the square root of that, because I want to take C squared and make it into a C, I get 16.398, and I'm going to round that off to 16.4. Might as well be consistent, round off to the nearest tenth. So in other words, I now know that the missing side right here is 16.4. Let me just double check that. Yeah, 16.4 right there. Okay, so notice we have all three sides. What's the only thing we haven't found is this angle, which I'm marking in gold right there, that acute angle. Well, every triangle adds up to 180. So if I just simply take 69 plus 90, that's the sum of these two other angles, right? that's 159. And if I just simply take 180 minus 159, well, now I know that that missing angle right there is 21 degrees. So I found all the angles and I found all the sides. Pause the video, guys, before I do the last problem. Okay, so we also, ladies and gentlemen, had this problem number 7 on the worksheet. Now going just a little bit faster, does everybody agree 41 is my reference angle? Notice the 14 is my hypotenuse, right? So I'm missing both the opposite and the adjacent sides here. Okay? Again, adjacent, notice, is right next to the 41. Notice how this side right here, which I just scribbled in green, is opposite of 41, right? So we have a choice here, guys. Do we want to do sine or cosine? Because again, using Sohcahtoa, some old hippie caught another hippie tripping over apples. We know that if I want opposite and I have the hypotenuse, I could use sine, or if I want to find the adjacent, I'll use cosine. Let's just use sine, okay? So hopefully you understand that the sine of that 41 degree angle right here, and let me clean up my work here now a little bit, kind of start over here. So we know that the sine of that angle 41 degrees is the opposite side. Guys, if it's okay, I'm going to call that O, that's not a 0, for opposite, over the hypotenuse, which is again, in this case, 14. Not 1.4, but 14. Let me just clean that up a little bit. Okay, so this one's much easier solved than problem 6. Notice how the ratio is in the proper order here, right? So I can get rid of divide 14 very easily. All I'm going to do is multiply by 14. Multiply by 14 both sides. Everyone agree 14 divided by 14 goes away, cancels out to 1. So notice the opposite has to equal whatever that is. And I just so happen to have done it already. Notice right here, guys, what's 14 times 41? It's 9.184. Again, let's round that off to 9.2, right? Okay, 9.2. So, cleaning up my work once again, notice I now know that we have the hypotenuse 14. We know that's 9.2. Now we need to find this missing side over here, the adjacent side, right? So how do we find the adjacent side? Let's go ahead and call it A still for adjacent. Well, isn't A squared plus B squared equal to C squared? And of course, B squared is the 9.2 squared, and the 14 is my C, right? And I just so happen to have done the math here already. So A squared plus, and if you notice, 9.2 is 84.64. 84.64. And that equals 14 squared. And 14 squared is 196. I didn't have to do that with a calculator, but go ahead if you doubt me. So can I now solve for A squared? Of course I can. All I need to do is minus 84.64 from both sides. Minus 84.64. And now I know that A squared is going to equal whatever this difference is. And I just so happened to have done it right here. 196 minus 84.64 is 111.36. So 111.36. Now this equals A squared. So does everybody agree we're going to do a square root of both sides? And now give me A equal to, and as you can see right here, the square root of 111.36 is 10.55, which if it's okay, I'll just round off to 10.6. Okay, so we know A is 10.6. So notice, guys, going back to my picture here, I now know that we have the 14, we have the, 9.2 here side, and now we know this missing side was 10.6, right? 10.6, 9.2, 14. Okay, Notice, only thing left missing is this angle B in gold. Well, every triangle adds up to what? That's right, 180. So if I take 41 plus the 90, those are the two angles given, that's 131, guys. And if I take 180 minus 131, well, that's just simply 49 degrees. So now I know angle B is 49 degrees. 49 degrees. Okay, that's 49 degrees. Okay, and guys, please pause the video and rewind it if you need to. Again, you ought to watch this more than once and maybe make notes out of this, especially if you're an avid. You can make really good Cornell notes out of this. But the key thing, guys, is we got to get very good at solving right triangles using Sohcahtoa and Pythagorean theorem. So until the next time I see you guys, bye.